Dear students, today we are going to discuss about the topic amines, general introduction, classification and basicity of amines. This is the unit, fifth unit, last chapter, aliphatic amines. General introduction, classification and basicity of. In this video, we have discussed about their introduction, classification and basicity of amines. Amines. The amines termed refer to number of alkyl group or aryl substituents bonded to the nitrogen atom. Amines terms refers to the number of alkyl or aryl substituents bonded to the nitrogen atom. The different kind of amines is there. This is the classification of amines. There are four type of classification: primary amine, secondary, tertiary and quaternary amines. Primary, secondary and tertiary, quaternary. These are the four type of amines: primary, secondary, tertiary and quaternary. The primary amines. In primary amines, only one of hydrogen atoms in the ammonia molecule has been replaced. In one of the hydrogen atom in the ammonia, in this case the RNH2 is the general formula of primary amines. Primary amino group RNH2 group. When NH3 have 3 hydrogen, one hydrogen replaced by an alkyl group, that is the primary amines. And only one of the hydrogen atom in the ammonia molecule has been replaced. That means the formula of primary amine is the RNH2. This R is a alkyl group. R is a alkyl group. These are the examples of primary amines. That is 1 amino propane and 2 amino propane. This RNH2, this NH2 is the primary amino group. Primary amino group. Next is secondary amines. In secondary amines, 2 of hydrogen in ammonia molecule have been replaced by alkyl group or aryl group. In case secondary amine, 2 hydrogen in ammonia molecule is replaced by alkyl or aryl group. Alkyl or aryl group. These are the examples: dimethylamine and diethylamine. Dimethylamine and diethylamine. So the two examples. This is the secondary amino group, that is ammonia containing 3 hydrogen atoms. 2 hydrogen atoms is replaced by 2 alkyl group, that is secondary amine. Next, tertiary amines. In case of tertiary amines, all of the hydrogen in ammonia molecule is replaced by alkyl group or hydrocarbon group, that is the tertiary amines. These are the examples of tertiary amines. Trimethylamine. This is the tertiary amino group. Tertiary amino group. What is the quaternary amines? The quaternary ammonia cation, also known as KUHS. Quaternary ammonia cation is also known as KUHS, are positively charged polyatomic ion. This is a positively charged polyatomic ion. Their structure is NR4+. That is the structure. The R being alkyl group or an aryl group. This is the, unlike ammonia ion, NH4+, unlike the ammonium ion. This is NR4+. This is a quaternary ammonium cation. Are permanently charged. Quaternary ammonium cation are permanently charged, independent of the pH of their solution. The quaternary ammonium salt or quaternary ammonium compound called quaternary amines in olefied farnels. This is the quaternary amines. The quaternary amines salt or quaternary ammonium compounds called as quaternary quaternary amines in olefied farnels are salted of quaternary ammonium cation. This is the quaternary ammonium cation. This is the quaternary amines, quaternary amines. These are the classification: primary, secondary, tertiary amines and quaternary amines. What is a natural nitrogen compounds? Natural abundances with the nitrogen compounds may occur in plant that are referred as alkaloid. Natural abundance with the nitrogen compound, many of which occur in plant that is referred as alkaloid. These are the examples, some examples of natural compounds, nitrogen compounds: serotonin and quinine, nicotine. These are the examples. Serotonin is an important neurochemical. That is example of primary amine. Secondary amine is example quinine. Quinine is the poison hemlock. Poison hemlock is the quinine. Next, nicotine. Nicotine is tobacco. Tobacco is nicotine. It's the tertiary amines. Next, IUPAC system of the following rules to name amines. Apply the following rules to the amines. IUPAC nomenclature of amines. The first one we have pick out, already we have discussed. The first, pick out the longest continuous chain carbon atom. The step is the identify the longest continuous carbon chain. In second step, this parent name comes from the alkane or the same number of carbons. Then second, change the E of the alkane to amines. Change the E of the alkane to amine. That is methanamine. When alkane E is replaced by amines. Next, second step is the change the E of the alkane to the amine. The third step is the locate and name any substance keeping the amine chain is numbered away from the amine group. Substances which are attached to nitrogen atom instead of the carbon chains are designated by an capital N. This is the example: methanamine. Another example: 1 on is the position, indicate the position, on dimethyl ethanamine. 1 on dimethyl ethanamine. In another example, NN dimethyl ethanamine. These are the example of aliphatic amines. Next, aromatic amines belong to the specific family which act as parent molecule. For example, an amino group NH2 attached to the benzene produces parent compound aniline. Aromatic amines belong to the specific family which act as a parent molecule. For example, an amino group NH2 attached to the benzene, that's a parent compound known as aniline. These are the example: aniline, N-methyl aniline, that is N-substituted aniline, N-dimethyl aniline. More examples we have discussed: IUPAC, name of, and also have common name. On amino butane, that is IUPAC name butanamine, N-butanamine, the common name. Next, another example: 2-amino 2-methyl propane, 2-methyl 2-propanamine, and tertiary butylamine. These are the more example: on methyl amine, amino propane, and dimethyl amino ethane. These are the example: aniline, indole, aromatic, dipyridine, heterocyclic alanines, amino compounds. Next, piperidine, pyridine, pyrimidine, pyrrolidine, pyrrole, imidazole. These are the examples, more examples of nitrogen containing organic compounds. Cyclic, aromatic, and aliphatic amines is there. These are the more examples of aliphatic and aromatic amines. Next, physical properties and characteristics of amines. The general features of amines. The first, the aliphatic amines, we have already discussed in about practical. The amines are fishy smell. The lower aliphatic amines are gaseous in nature with the fishy smell. The primary amines with a 3 or 4 carbon atom are liquid at room temperature, whereas higher on are solids. The primary amines with a 3 or 4 carbon atom they are liquid at room temperature, whereas higher ons are solids. Next, the aniline and other arylamines. Aniline and other arylamines generally colorless, but get colored if stored in an open due to atmospheric oxidation. Aniline is colorless, but when oxidation it's become colored. Lower aliphatic amines can form hydrogen bond. Lower aromatic amines can form hydrogen bond with the water molecule, hence they are soluble in water. Lower aliphatic amines are water soluble. Increase in size of hydrophobic alkyl protein increase the molar mass. Increase in the size of hydrophobic alkyl. Alkyl group is hydrophobic. What do you mean by hydrophobic? Increase in hydrophobic alkyl group that increase the molecular mass of amines. That increase the molecular mass of amines. Increase in the size of hydrophobic alkyl part increase the molecular mass of amines, which result in decrease in its solubility in water. Understand? Higher amines are insoluble in water. Lower amines are soluble in water, but higher amines are insoluble in water. Because of the hydrophobic nature of alkyl group increase the molecular weight of the amines. Next, organic solvent like alcohol, benzene and ether that are readily dissolved in amines. That are readily dissolved, the organic solvent like alcohol, benzene and ether. Then alcohol have higher polarity as compared to amines. Alcohols have higher polarity as compared to amines, hence they are form a strong intermolecular hydrogen bond. The alcohols have higher polarity as compared to amines, hence they form a stronger intermolecular hydrogen bond. Primary and secondary amines are often engaged in the intermolecular association as a result of hydrogen bond between nitrogen of one and hydrogen of other molecule. Primary and secondary amines are often engaged in intermolecular association as a result of hydrogen bonding between nitrogen of one and hydrogen of other molecule. This intermolecular association is more permanent in case of primary amine as compared to secondary due to availability of two hydrogen atoms. In case of primary aromatic amines, the availability of two hydrogen atoms, the intermolecular association is easily possible, more prominent. Intermolecular association is more prominent in case of primary amines as compared to secondary or tertiary. It is due to the availability of two hydrogen atoms. Next, tertiary amines are there is no intermolecular association due to absence of free hydrogen atom of bonding. Therefore, in case of tertiary amines, they have no hydrogen atom in this tertiary amine. Therefore, tertiary amines no intermolecular association. No intermolecular association is possible in case of tertiary amine. It is due to the absence of free hydrogen atom for bonding. Next properties. The first properties we have this general features of amines are fishy smell. Lower amines are soluble in water, but higher amines are insoluble in water because of the size of hydrophobic alkyl group increase the molecular weight of amines. Generally aniline and aryl amines are generally colorless, but they are colored due to the atmospheric oxidation. Then lower amines, primary amines are liquid at room temperature, whereas higher ones are their solids. Intermolecular hydrogen bonding is possible in primary and secondary amines, but tertiary amines intermolecular association is not possible due to the absence of hydrogen. Next, we have discussed about the basicity of amines. It's a very important topic, basicity of amines. The basicity of the amines are basic because they possess pair of unshared of electron. Amines are basics. They possess a pair of unshared electron. Possess a pair of unshared electron. Very important point. Pair of unshared pair of electron in case of amines. It is which they can share with other atom. The unshared electrons create electron density around the nitrogen atom. Which they can share with other atom. Their unshared electrons create an electron density around the nitrogen atom. The greater electron density have more basic the molecule. The greater electron density have more basic group that donate or supply the electron will increase the basicity of amine. Group that donate or supply the electron will increase the basicity of amine, while group will decrease the electron density around the nitrogen decrease the basicity of molecule. Understand? Greater the electron density have more basic the molecule, but in case of electron decrease the electron density around the nitrogen decrease the basicity of molecule. Due to the property of alkyl group attached to the nitrogen of the amine, electron density around the nitrogen atom increases due to the electron releasing ability increases. Understand? It is due to the property of alkyl group attached to the nitrogen of the amine, the electron density around the nitrogen atom increase due to which its electron releasing ability increase. Due to the greater and easier release of electron in the alkyl amine, the molecule become more basic than ammonia. Understand? Due to the greater and easier release of electron in alkyl amine, the molecule become more basic than ammonia. Wherein ammonia in no such releasing group attached, so obviously basicity of ammonia is much less than that of an alkyl amine. You understand? In case of this is the ammonia have lone pair of electron, free lone pair of electron, but in this case of alkyl amine, the alkyl group is the electron releasing group. They have electron releasing group, therefore more basic in nature. It have more basic in nature than ammonia have less basic in nature. It is due to the presence of electron releasing alkyl group in present in amines, primary alkyl amines. Alkyl group has electron releasing group. This is the basicity of amine. Very important topic, basicity of amine. The basicity is due to the electron density. Greater the electron density have greater basic in molecule, but decreasing the electron density around the nitrogen decrease the basicity of molecule. This is the basicity of amines in the gas phase and aqueous phase solutions are varies. In gas phase, the order of basic strength is given below. In this case, tertiary amine have greater basic. This is the order of base strength is given. Ammonia is less than primary amines, less than secondary amines, less than tertiary amines. Primary, secondary, tertiary. This is the increase in basicity order. The tertiary amines are more basic in nature in gas phase. But in aqueous phase, the order of increase in basicity is secondary greater than primary greater than tertiary greater than, this is the increase one, secondary greater than primary greater than tertiary greater than ammonia. This is the increase. This is the secondary amines are more basic than tertiary amines. In aqueous solution, the order of basicity is the secondary greater than primary greater than tertiary greater than ammonia. But in case of gaseous phase, primary greater than tertiary greater than secondary greater than primary. This is the increasing basicity. The difference in basicity order in gaseous phase and aqueous solution as the result of solvation effect. It is due to the solvation effect. Amines in water solution exist as ammonium ion. Amines in water solution exist as an ammonium ion. In water, the ammonium salt of primary and secondary amines undergo solvation effect due to hydrogen bond. The primary and secondary amines have undergo solvation effect due to the presence of hydrogen bonding with the water molecule. In gaseous phase and aqueous solution, due to the indifference in the basicity order is gaseous phase and aqueous solution as the result of solvation effect, the amines in water solution exist as ammonium ion. The solvation effect increase the electron density of the amines nitrogen to greater degree than the inductive effect of alkyl group. The solvation effect increase the electron density of amine nitrogen to greater degree than the inductive effect of alkyl group. Understand? The solvation effect increases the electron density on the amine nitrogen to a greater degree than the inductive effect of alkyl group. Primary amine, the water, ammonia salt RNH plus OH minus. The secondary amine RNHR plus RH2O RNH2 R OH minus. Tertiary amines RNR2 plus H2O R NH R2 plus OH minus. Tertiary ammonium salt, secondary ammonium salt and primary ammonium salt. Next on question, the comparison in the basicity of the aliphatic amines and basicity of tertiary amine to be the greatest, followed by secondary and then primary amine. But this is not so. The order of basicity of ammonia less than primary amine equal to tertiary amine less than secondary amine. Explain why. This is due to the steric hindrance effect and solvation effect. This is unexpected order of basicity is due to the steric hindrance effect. The size of alkyl group. More than that of hydrogen atom. So alkyl group would hinder the attack of hydrogen atom, thus decrease the basicity of molecule. So more number of alkyl group are attached, lesser will be basicity. So this decreasing basicity will be primary amines greater than secondary amine greater than tertiary amine. Next, solvation effect. When amines are dissolved in water, they form protonated amine. The amines dissolved in water, they form protonated amine. Intermolecular hydrogen bond will be occur, association will be occur in amines. The number of possibilities hydrogen bonding also increases. More number of hydrogen bonding in more is the hydration that is released in the process of formation of hydrogen bond. More number of hydrogen bonding, more is the hydration that is released in process of formation of hydrogen bond. The more hydration energy in the molecule, more stability of the amines. The experiment indicate the term of hydration energy that tertiary amines are the least stable, followed by the secondary, followed by primary amines. The primary tertiary in case of tertiary amines are least stable, followed by secondary, followed by primary amines. The more hydration energy of the molecule is more stability of the amines. These are the answer. It is due to the steric hindrance effect and the solvation effect. This can be explained by the base of following reaction. In primary amines, RNH2 H2O, they form RNH3 plus OH minus ion. In case secondary amine, they form R2NH2 plus OH minus. In tertiary amine, R3N plus H2O, it will form R3NH R3. This is the R3 NH plus OH minus. So the number of hydrogen bond possible. So the number of hydrogen bond is possible when primary amines are dissolved in water is the greatest, implying that they are most stable species of amines, the least being the tertiary amines. So the number of hydrogen bond is possible when primary amines are dissolved in water is the greatest, implying that they are most stable species of amine, the least being the tertiary amine. The combined effect of pushing effect of alkyl group, that is a inductive effect, plus psi effect, steric hindrance, the solvation of amine causes the basicity order, not salvation, it is solvation. So solvation amine cause basicity order. Basicity of tertiary is almost the same as that of primary, and therefore is the ammonia is less than primary amine, that is almost same to the tertiary amines less than secondary amine. These are the basicity of amines. Basicity of amine is very important portion. Basicity of amine is due to the steric hindrance effect and solvation of effect. It is due to the steric hindrance effect and solvation effect. And also have electron density. Greater electron density have more basic molecule, lesser electron density have lesser basic in nature. Okay, thank you all.